Great. So I'm joined by Koji. How you doing today, man?
Doing well. How are you?
Yeah, I'm great. Thanks. Great to have you on. I'd love to just quickly get kind of a 2 to 3 minute rundown on who you are and what your story is.
Sure. Sounds good. So I'm Koji, Japanese American. Grew up on the East Coast of the US. My undergrad was in engineering, and I started off on the not so good side of the climate spectrum. I was working at ExxonMobil for 6 years. So that was in kind of the global projects division, working mainly on downstream projects. And I definitely learned a lot, especially in the energy space. And the last project that I worked on was a $800 million hydrogen project, which was the largest in the UK. Of course, that's gray hydrogen, and but that's what we're looking to display. So, and then I think it became quite clear that ExxonMobil is going to be the very last oil major to transition. I don't know if I should say that publicly, but that's my opinion at least. And so I left. I started working on a couple different climate tech startups, trying to repent for my sins. So I was a early hire at a company called Last Energy, which is doing small modular nuclear reactors. Raised 3 million seed, and that's US based. And then I was the first hire at a company called Neocarbon, so based in Berlin, doing direct air capture using a cooling tower. So they raised 1.25 million pre-seed, and now I'm doing green hydrogen. So obviously, I'm very interested in these emerging kind of breakthrough innovations that have the biggest potential to make huge contributions to the climate crisis. And I'm actually also finishing on my MBA at London Business School, so I've got about 2 weeks left at the time of this recording classes.
That's awesome, man. I really love your kind of. It's a bit of a patchwork background, but there's also a clear progression that you're working towards, like a bigger vision. Before we dig into your company, I just want to ask as well on the MBA point, kind of why did you decide to do it, and kind of what value is it bringing to you in the moment? Because a lot of people go straight from industry, into making a startup, and you often kind of hear about the lack of commercial experience, meaning that it's quite difficult to raise from investors, etc. Is that one of the value adds of the MBA that you found?
Yeah, so my background, starting off as an engineer, and most of the work I was doing at ExxonMobil was engineering. So it is kind of mix of technical, a little bit of project development, but I knew I wanted to eventually start my own company in the climate space, especially, I guess, we talk a lot about additionality in the climate space, and I was kind of considering my own additionality and what's the best value I can bring. And certainly I can work at one of these companies and progress along a technology and do my part there. But I felt, combined with my technical background, and especially within the energy space, and then marrying that up with an MBA, that would give me the right skill set to be able to identify these new up and coming, like, breakthrough innovations, and really lead that through into commercialization. So I my work at both Blast Energy and Neocarbon, they're both time boxed, which is the reason I left. One was right before I started the MBA, and the other one was kind of an internship between my first and second year. So it's not like I left on bad terms or anything, and they're both going well. And I would have been very happy continuing on with either of them. But I think the most value that I can bring is trying to identify this completely new potential and innovation, and trying to push that along. So the MBA was a way to help round that out, and definitely the network that it brings, I think has helped immensely, for sure.
I think there's a great lesson there as well for kind of early deep tech founders or wannabe founders, such that kind of taking the necessary steps to build up your skill set before you actually take that dive in at the deep end. Not only the MBA, but kind of these shorter term internships to kind of wet your beak a little bit in the startup world and look into more climate solutions. I think that's really intelligent.
Yeah.
So let's go straight on to Key Hydrogen, then your startup. Can you talk about kind of what you guys do and why did you see this as an opportunity to kind of put all of your eggs into this basket?
Yeah, so Key Hydrogen, we are a kind of deep tech climate venture, and the real goal is to make cost competitive green hydrogen, and we do that by sourcing it from a technology called biomass electrolysis. So I guess to give the broader background for a wider speaker or listening base, in terms of today the world has a massive problem, an existing problem that although we talk about hydrogen and all the new things that it can or can't do, there's 94 million tons of hydrogen that the world is already producing today. It's an existing $150 billion market, but 99% of that hydrogen is sourced from fossil fuels. And that leads to direct emissions of over 830 million tons of CO2 every year. So that's kind of similar to the aviation industry. So that's a massive problem today that we can solve or need to solve by displacing that with what we call like carbon-free hydrogen or green hydrogen. And today, the really only commercially way to do that is a technology called water electrolysis. So use renewable electricity to split water into hydrogen and oxygen. But the challenge there is it's extremely energy intensive, and the cost of that ends up kind of in the kind of $5 to $6 a kilogram mark, whereas gray hydrogen, the fossil fuel based hydrogen, is like $1.50 to $2 a kilogram. So, at the end of the day, it's a commodity chemical, and unless we can get to cost parity, we're not going to see kind of significant drivers to displace it. So, when we started looking at tackling this issue, we went back to just the first principles of, okay, well, break it down. What are the biggest cost drivers for water electrolysis? Well, it's very clearly about 70% of the levelized cost is from the energy demand. So you need to put in a lot of electricity to produce this hydrogen. And to give a sense, today these water electrolyzers will require maybe around like 50 kilowatt hours of electrical input to produce 1 kilogram of green hydrogen. And that's around the same amount of electricity that a UK household will use an entire week. So a weekly consumption of households' electricity, and yet we need to get that down to $2 a kilogram. So, very tough challenge. And it's not really even a technology problem that we can solve with more efficient electrolyzers. There's a thermodynamic kind of limit, a minimum amount of energy you need to split water apart. And that barrier is very high. So there's a very high floor. So when I talked about 50 kilowatt hours, there are some electrolyzers that can get that down to kind of 45 or 42. But fundamentally, there's a limit of around 40 kilowatt hours of electrical input you still need. And that's like pretty much at 100% efficiency. So you cannot get below that with water electrolysis.
So just as a quick recap then, you're really kind of lowering the energy required to create green hydrogen by essentially thinking about it from first principles and changing out the water for a different feedstock.
Exactly. So because we found because of that barrier, you essentially have to get your hydrogen from somewhere else instead of pure water splitting. So there's two main camps. You can either source it from methane or natural gas, which is what's done today, or there's another kind of technology called methane pyrolysis, which you get carbon black, so like sequestered carbon as a byproduct. So it's not emitted, but you're still sourcing your feedstock from methane, right? And there's significant emissions from methane extraction and leakage. So we see that as kind of an interim solution. So we're focused on the more end game state that we see, which is sourcing it from biomass. And when we talk about biomass, it's specifically we're working with liquid biomass. So that can be waste from breweries, from paper pulp production, sugar manufacturing, or even down to agricultural waste. And essentially we instead of kind of oxidizing the water and creating the oxygen there, we're oxidizing the biomass, breaking that down into these shorter chain carbon acids, which are actually chemical commodities that we can sell as co-products. But that reaction of breaking down that biomass is much less energy intensive. So when I was talking about, today electrolyzers require maybe 50 kilowatt hours, they can go down to 40 kilowatt hours, but that's the fundamental floor. For us, biomass electrolysis has been lab demonstrated to produce hydrogen down to 10 kilowatt hours. So it breaks through that fundamental barrier, and that's where we see the huge step change of being able to produce green hydrogen down to the $2 a kilogram mark by significantly reducing that energy requirement, plus also making useful chemical co-products that we can sell.
Right, yeah. I really like the angle, just to kind of reiterate if anyone missed it, that you're using waste streams to kind of source of these biomass products for the inputs to the electrolyzers, which of course, is beneficial for the environment, as well as you having an additional revenue stream from what's produced. Is your plan always to kind of produce from, as you said, the waste from breweries, or are you looking to widen the range of feedstock that you take in the future?
Yeah, we definitely want to widen it. So that's where we'll start. And it's a bit easier to work with that because, it's been boiled and mashed. So it's a bit more processed and it's known what's going to be in it. But in order to scale it, we know we need to start looking at more kind of agricultural feedstock. So, if we talk more around like woody waste and crop residue, then it's hundreds of millions of tons, if not billions of tons, that's produced globally. And we say kind of biomass waste for shorthand, but we do know sometimes in these industries they are very much treated as co-products. So like brewers spend grain at breweries today, they kind of spend some energy drying it out, and then they pelletize it, sell it off for animal feedstock. So they do get some margin there. So in our economics, we are still accounting for purchasing that biomass. We're not assuming we're getting it for free, but still, even with taking into account those costs, we see it being cost competitive.
No, yeah, makes a lot of sense. I think in the context of, you see all of these business models where the startup essentially comes on with their hardware and they tack onto an existing power plant or waste producing factory, whatever it may be, and then kind of employ a licensing model whereby they can just license out the technology instead of having to build it all themselves. Can you talk about, I understand you guys are adopting that licensing model. Can you talk about the pros and the cons of that and why you decided to do it? Because I remember when we last spoke, you mentioned a really interesting point around kind of US investors liking to keep all of the pie, and EU investors, obviously generalizing here, typically like to have this kind of asset light model. So can you talk about, why exactly you chose licensing?
So in terms of the business model, yeah, we're focusing on this asset like kind of technology licensing play, because we know as we scale up, this becomes a very asset intensive process, and we want to focus on what's the differentiating factor that we bring, what's our expertise, which is the technology, and continue to innovate on that. So we want to remain a technology company as opposed to becoming like a logistics company or a manufacturing company, because there are existing companies today that do those things. There are plenty of hydrogen project developers, even like moving around biomass. There are operating biomass power plants today where companies move around millions of tons of biomass. And even on the electrolyzers, we're not looking to make a new bespoke electrolyzer and have to manufacture that ourselves. Our technology will be compatible with kind of off-the-shelf alkaline electrolyzers. So we can rely on these building global supply chains and essentially partner out those asset-intensive pieces while we focus on the technology licensing bit. So that's definitely a business model that's resonated quite well in Europe. The difference we see a bit when we speak with American investors is much more that kind of go big or go home mentality of why are you limiting yourself to this slice of the pie? Like, you should capture the whole thing. You should own and operate and build. I think that just the risk appetite is much higher, and also the capital availability is much higher. So, I've heard people just say, if it's a good technology and the business model works, then like capital's unlimited. Like, don't be worried about being capitally intensive. So it is a bit of a it's quite interesting how stark of a difference it is, the two.
No, that's fantastic insight again. And I know some startups are kind of looking at contract manufacturing and a bit of revenue sharing, which I think some VCs see as like almost like a happy middle ground. Is that something you explored at all, or you like, no, we're gonna purely be kind of a technology R&D company and leave all of the manufacturing to the external players?
Yeah, we especially, what we might get into is more kind of on the project development, or also just like combining the different industries, because electrolyzer companies today and traditional green hydrogen project developers aren't really speaking to these like large biomass producers, whereas as we scale up the technology, we'll be building those relations. But we don't see ourselves really getting into the manufacturing per se. That is kind of the most kind of capital intensive part, and just scaling manufacturing ability is such a different expertise area entirely. I will say, I mean, this is very much our strategy now, but the next kind of 18 months, 2 years is very much continuing out this laboratory prototyping, building our demonstrator. So regardless of the strategy, our next kind of near term is the same, and depending on how the macro trends play out, of course, we'll remain flexible.
No, also makes perfect sense. And then I kind of want to zoom out a bit to more of a general hydrogen discussion. I remember last time we spoke off camera, you made an interesting point. You said hydrogen should reach cost parity with fossil fuels, and then we should start thinking about the use cases afterwards. I just wanted to know, I wanted you to clarify that sentence. And, because I've spoken to a number of VCs, and obviously, even if they specialize in hydrogen, they say things along the lines of, okay, find the use case first and then try and solve for it. Is that what you meant by that statement, or is it a bit more nuanced?
Yeah, I think it's more. So when I talked about that, it was, getting green hydrogen to cost parity with fossil fuel based hydrogen, which I mentioned is already an existing huge market, and there's a big demand for that there. And if we can get cost parity green hydrogen, then then we can start working to directly start displacing that. I think especially investors coming into the industry, they get very excited about these emerging use cases for hydrogen, which I'm also a big fan of. Especially, I don't think it's the best applications, or they're never really going to be around passenger vehicles and home heating. Those we have simple kind of electrification options for, and it's way more efficient to electrify. But it's those hard to decarbonize sectors, hard to electrify sectors like heavy industries, heavy shipping and transportation, steel manufacturing. Those are all very exciting kind of avenues of where hydrogen can go and start decarbonizing even more aspects of industries. But I don't think we have to be so reliant on saying, okay, well, we're going to wait until these industries or these new applications take off, and then we start investing in making green hydrogen cheap to do that. We should be doing that anyways, because if we are serious about net zero, then we know we have to displace even existing gray hydrogen with green hydrogen.
No, that makes perfect sense to me. And I think another argument would be that we do need regulation to kind of get that initial spark going. Because of course, in a lot of these applications, particularly in heavy industry, it's going to be very hard to achieve cost parity in the near term without deployment. And obviously, it's a bit of a catch-22, because like, how do you deploy if the customer's not going to buy with a green premium? Do you kind of agree with that in terms of we do need these regulations to really kickstart hydrogen adoption, and then only at scale will it actually achieve cost parity and theoretically reach some kind of inflection point whereby, the uptake takes off?
Yeah, I mean, it is a very much the same with kind of all of these other, clean tech solutions around solar PVs and electric vehicles. They all came into existence, or it accelerated through a lot of subsidies or other regulations. So I'm definitely for anything that helps accelerate the speed of deployment and these cost learnings. But I think what's really important to keep in mind is we always have to view subsidies as like an interim solution. We can't have these technologies become reliant on subsidies, which is the same way solar and EVs went. It helped kickstart, but eventually the subsidies die away. As long as you have a pathway to becoming cost competitive. So that's why we're very pushing on our technology, because we see a very clear pathway to being cost competitive without subsidies. We see that as a real challenge with water electrolysis, because I was mentioning that fundamental energy barrier, which basically makes you reliant on extremely cheap electricity prices to make that get down to cost parity. So when you look at all these cost curves, they're talking about getting down to electricity prices of like $15 or $20 a megawatt hour, which is, in places like Australia, Chile, Middle East, where you can get cheap renewable electricity. I think that works. But in many other places, especially Europe, I see that as a big barrier. And also importantly for us is the opportunity cost of all this electricity, right? Because it's not just the cost of it being cheap, it's so much of it. And again, to provide some context, when I was talking about the 94 million tons of hydrogen that we produce today that we need to decarbonize, if you want to displace that with all of it, with green hydrogen tomorrow, with 100% efficient water electrolyzers, you would need more solar. You would need more electricity than we have of entire solar and wind electricity available today. So it's the amount of electricity that we would need to deploy solely for hydrogen production, if we're going the route of water electrolysis, is immense, and we can't even deploy it fast enough to electrify the things that we want to. So that's how I see it kind of play out.
Yeah, it's really insightful. So it's really an energy problem that you guys are looking to solve, and then kind of a problem or an conversation topic that always comes up is hydrogen infrastructure and all of these barriers to actually rolling out hydrogen. Okay, it's great that we can get the production down, but we have to look at the whole value chain and think about distribution and the offtake and what are all of the end use cases. Obviously, you guys are dealing with production. Do you see any barriers in terms of the distribution and obviously these end use cases kind of being slow to adopt? What are the biggest kind of fish to tackle there?
Yeah, I mean, huge barriers all along the value chain, which is what makes it very tricky. So yeah, transportation, storage. I guess where a lot of countries seem to be going is focused on these regional kind of hydrogen hubs and valleys, targeting industrial clusters, building out the common infrastructure to move around the hydrogen. So I think that's what's going to make the most sense. And at the end of the day, that's also where we would like to kind of target once we get to more centralized plant scale, is co-locating the production with the off-takers, right? Because so you try to minimize as much as possible that transportation piece, as at least regionally. But this is again where when we zoom out even further, there's a lot of reports saying actually the cheapest places you can make hydrogen kind of cost competitively is only going to be these very select regions like Australia, where then you have to ship it out. And then that's how we build out the global infrastructure supply of hydrogen. But again, that's because they are saying actually these are the only places where we can get such cheap electricity where it makes sense to produce hydrogen. Whereas for us, we're opening up the scope of where you can deploy hydrogen cost competitively, because we're not so reliant on that cheap electricity price.
Yeah, that's really insightful. Again, I think someone told me that electrolyzers at the moment only really make sense in a centralized model. You know, if you kind of run these models and you look at the analysis, that it only makes sense cost wise to have these things at scale in a centralized manner. Do you see it the same way, or do you kind of see electrolyzers, you know, maybe in the next 20 years turning out like solar and wind have, which is a lot more decentralized nature?
Yeah, I mean that's interesting. I guess maybe just because of the infrastructure that's not built out yet, but electrolyzers are pretty much inherently modular, so you can just stack more of them together. So I see flexibility there, where of course there's going to be economies of scale when you centralize it, and especially if you're tackling these huge use cases of hydrogen, of these industrial use, then yeah, you just need to make a lot of it in that one location to meet the demand. But I wouldn't say that there's nothing kind of inherently stopping also a more decentralized model as well, especially if we expand out use cases for this hydrogen.
No, absolutely. That makes a lot of sense as well. And then you kind of touched on storage. I know we talked about this last time in our conversation in terms of taking electricity, storing it as hydrogen, and then converting it back into electricity to kind of obviously solve this big renewables storage problem isn't an effective solution just because of the losses involved, you know, and all the leakages and these conversion factors. Do you think it ever makes sense? Because I've obviously talked to some people who say really bullish on hydrogen storage and say, okay, there's an existing natural gas pipeline, you know, under the UK, for example, that we can exploit. It should be used for kind of seasonal or longer term applications, such that you're not always converting it back and just keeping it there as almost like a base load kind of power. Do you agree or disagree with that?
Yeah, I mean, I'll say honestly, I haven't looked too deeply into the storage application specifically, but I definitely see the potential benefits there, because in general, obviously, as we electrify the grid to more renewables, we will need a lot, longer term duration storage. And even if it's not the most efficient, which the round trip efficiency is certainly not good for hydrogen and returning it back to electricity. It still may be worthwhile until we find kind of a better solution. So I'm all for kind of keeping all the cards on the table, and not saying, this doesn't make sense because of X, Y, Z. I feel like there will be definitely some applications where it will make sense. Will it be the dominant technology? I probably not, but I don't know.
Yeah, I agree with you there. And kind of going off that, it sounds like you're probably a proponent of nuclear as well, given your background. Can you talk about kind of the pros and cons of nuclear, and obviously all of this furore around, you know, Germany closing their power plants, a lot of controversy around that. Do you see nuclear as something that we need to continue to invest in, and that can continue to provide like a very consistent, reliable baseload?
Yeah, I mean, obviously it does get very controversial, but trying to stay a bit high level, you know, same philosophy. I think we need to look at all technologies, and especially without a clear solution in long duration storage, we will need significant amounts of base load clean energy. And nuclear is, if it's not nuclear, then it's hydro or geothermal, or maybe tidal. But hydro is very location dependent, as is geothermal, and tidal is very much emerging. So nuclear is a kind of a really good and proven, obviously, technology that provides baseload clean energy. And yeah, there are of course a lot of concerns, but again, you just have to look at what options do we have if we are being serious about trying to decarbonize the electricity grid.
And then can you talk more about small modular reactors, given your background? I know you kind of worked in there for a shorter period of time. Can you maybe explain to any listeners, what exactly they are and what are the pros and cons? Because I feel like, if you just scan the internet and do a quick cursory read about these things, you kind of assume that you could almost like have them in your house, or like there's these kind of small, very modular reactors, as the name implies. But in actual fact, most of them need to have special kind of facilities. Most need to have some kind of hole dug in and they put under the ground. Can you just elaborate more about the landscape there?
Yeah, so definitely, yeah, they're called small modular reactors, but they're small compared to normal nuclear plants, but they're not small, right? They still will be kind of like, could be like factory size and enough to power like a town. But essentially, what it's trying to solve there is taking aside kind of the safety concerns of nuclear, which there's plenty of debate around. It still goes back to the economics, right? Because if it's so uneconomical to deploy nuclear, which kind of it has been shown through kind of previous projects, then it still doesn't make sense. So what small modular nuclear reactors are trying to do is get away from these huge, 10 billion, 10-year nuclear power plants that always face a bunch of capital overruns and delays, and that feeds into the negative public perceptions as well. And move from a project model to more of a product model where you get something nice and standardized. It's smaller, but you know how to build it, and then you kind of keep iterating, making it cheaper, getting away from these very specialized stick built or built out into the field, and that's where a lot of these expenses start growing. So yeah, they're not that small, but it's really looking at a different business model to drive down the costs. And it's interesting because it's not just nuclear that's going this way. The last few projects I was doing at ExxonMobil, even like in traditional oil and gas, it's looking at the same strategy because they're realizing it is cheaper to make things modular. So instead of even these big plants that we were building, instead of having a bunch of people out in the field and field erecting, as they would call, sometimes they'd be like a fab shop somewhere else in a different country where they build a lot of these facilities in kind of this modular fashion, and then just put it on like a giant barge and move it over to the site. So it's similar, and they're doing that, yeah, because it drives down the cost. So it's kind of a similar idea there.
Yeah, it makes a lot of sense. And has this technology been commercialized? To what degree has it? Kind of what are the use cases at the moment? And maybe thinking about what do you see the best use cases for it in the next 10 years?
Yeah, I haven't followed too closely, but I have seen kind of, snippets here and there. I don't know if they've fully commercialized yet, but there's definitely strong interest, especially like countries like the UK are quite bullish in small modular reactors. So the government's put a lot of funding towards that. The best use cases, I mean, definitely anywhere where it'll bring the best kind of grid stability or directly displacing carbon intensive emission sources or other forms of electricity production, but also kind of remote locations is actually quite interesting. Like if you have like a remote mining town, essentially, which needs a lot of energy demand, and because it's so far off the grid, maybe they're just run on a bunch of like diesel generators, which are kind of the worst in terms of environmental impact. Displacing that with kind of a smaller reactor would definitely be really good.
And again, the name's small, but I actually read that some of these reactors can theoretically power small towns and villages and all of this stuff quite easily. So yeah, it makes a lot of sense. And then in the same vein of kind of emerging technology, something we've obviously heard about for a long time is carbon capture. And you have a little bit of experience in the space again. Kind of what are the problems there? Is it just simply a case of cost again? That is the barrier for adoption? And if so, how can we get that down?
Yeah, I mean, it's all cost. It's always cost. And I mean, yeah, it shouldn't be too surprising, I guess. It's you're trying to sequester out carbon out of the atmosphere where CO2 is like 0.04%. So it's extremely dilute, and so it just requires a lot of energy to try to concentrate that out. So yeah, there's the direct kind of atmospheric capture, but then there's also other technologies that are looking at like enhanced rock weathering, so accelerating natural processes, or kind of relying on biomass to capture that CO2 and then doing something with that biomass, whether you store it. So yeah, it's all about driving down those costs, and actually it does tie back a little bit to what we're doing, because we're also starting with kind of biogenic carbon sources like biomass. The difference for us is, as we're producing hydrogen, all the carbon stays in liquid form. Hydrogen's our only gaseous product, so no CO2 is emitted and released into the atmosphere. And actually, the carbon stays in these useful liquid forms that we can sell as co-products. So technically, that can also be counted as a form of, I guess, carbon reduction, removal, if it's not emitted and starting from biogenic sources. Is not an angle that we're super focused on the moment, but definitely an option.
No, absolutely, yeah. Of course, within the context of your startup, and I know kind of CO2 sequestering the carbon is very popular. You have all of these direct air capture kind of fittings, retrofitting on existing plants, and you can theoretically have a carbon neutral system. I think another really interesting one is, I think you alluded to it, but putting it back into concrete and building mixing materials to improve the mix qualities. Are there any other really interesting, things on the horizons you may have read about in terms of actually dragging the CO2 out of the air, and not just kind of obviously reducing the greenhouse gas emissions and hopefully reversing climate change, but using that carbon in really useful end products?
Yeah, I think that's most in terms of like durable storage. That's mostly what I've seen, is like sequestering it into like building materials, whether it's concrete. There's also this whole field around like biochar, right? So you take kind of biomass again, you kind of pyrolyze it, and then you can use that as building materials, or in sometimes kind of plastic replacement. So I think the whole ecosystem around use cases for carbon, captured carbon, and having durable storage for it is really exciting. Using it as fertilizer, I've seen as well. So yeah, it's really quite interesting.
Same, yeah, it really excites me as well. Just seeing the rate of development and where it's going to go in the next 5 to 10 years, it really picked up. And then maybe, man, just to finish off, some advice for kind of founders as well, if we bring it back to startups. I know you're kind of a member of, I think, more than one accelerator, if I'm not mistaken. What are the values of accelerators in the context of deep tech startups? Because I've spoken to the guys who run various university spin out courses and this and that, and they often cite problems of this accelerator had too many scientific people, or there were too many finance people that didn't understand the science, and there's not really that blend. And I think a model that seems to be emerging that works quite well is really having this strong ecosystem where up and down the value chain, you bring in the right advisors and the right people that can help these startups grow depending on where they are in their journey. Do you agree with that statement at all? Is there any other insights you have around accelerators?
Yeah, I mean, I think you summarized it quite nicely. So yeah, we were born out of the Carbon 13 kind of venture builder program. And that's kind of explicitly what they try to do is, so it's bringing in individual founders that join the program who specifically want to launch a venture in the climate space, but don't have a team, not necessarily even an idea. And the first phase of that program is the teaming, where you're speaking with all these other people, finding the right co-founding team around a specific idea. But they purposely, the cohort that they bring in is like 50% commercial, 50% technical. But it's not like they force you together and say like, okay, you 2 or 3 will be the perfect match. So talk to each other. It does. The teams do kind of grow organically, but you have the right diversity of skill sets that it makes sense that you're going to end up with a team where you'll have that strong technical expertise and a strong kind of commercial expertise. So I think Carbon 13 is a really good program that mixes those two. And yeah, we also joined the Undaunted Greenhouse Accelerator, which is been, also fantastic for us. We've been in for about 2 months, and kind of the resource and again the network they provide has been really invaluable.
Yeah, that's the Imperial College one, right? Yeah,
Yeah,
fantastic. Well, congrats again, because it's not easy to get onto even one accelerator or venture builder course. So that's really great work. And then maybe as a final point before we wrap up, kind of something I ask all the time, which is one piece of advice for deep tech founders. Obviously, you're not doing something in software where you can keep iterating your product all the time, and it's relatively easy to go out and find customers. Just give me the kind of insight into what hardware founders, deep tech founders should think about when starting a company.
I mean, I feel like I should be the one asking for advice. Like, as in, we are still a very new venture. We officially incorporated the company in December of last year, and we're raising our pre-seed. So still very new for us. But I would say, yeah, it is a very different approach, especially in London, where historically a lot of the startups have been in the more digital fintech kind of SaaS space. So finding the right investors to speak with, first of all, we learned that very quickly in terms of like the timelines that we need, the amount of capital that we need to really get going. It's hard for a generalist fund to kind of suddenly shift gears and say, actually, yeah, let's go into deep tech investments, just because they might not have the expertise or the expectations. Not to say that we're not speaking of any generalist funds. I think there are definitely an emerging group that, when they're focused on climate, they're realizing, okay, actually, if we need step change solutions, it's got to be something in the hardware and deep tech space. We can't just make a new app for something and have that solve climate change. So yeah, it's speaking to the right investors and building that right ecosystem, which it's not as established in kind of London, but it's definitely growing. And within Europe, I think there's certainly a sense of understanding that that's the direction that we'll need to go as we get more serious about tackling climate change.
Absolutely. Thanks for that advice. I completely agree as well. What really pleases me is there are a number of kind of, these smaller shops either dedicated solely on energy transition or hydrogen or a specific part of deep tech that are kind of popping up all around Europe and the UK. And, even kind of American VCs that are looking into Europe now and kind of setting up a UK arm. So it's really good to see these kind of investors maybe getting a little bit out of the traditional VC comfort zone, or at least what has been for the last 10 years, and not making, as you've alluded to, all these kind of copy-paste SaaS apps over and over. It just gets very tedious after a while, but actually trying to kind of create real solutions that affect, the atoms and not just the bits. But Koji, it's been an absolute pleasure having you on, man. Great to talk about hydrogen and your company and everything. Really insightful. Just to finish off, do you have any call to actions that you'd like to do?
Well, we are fundraising, so we always love speaking to investors, but I suspect by the time that this is released, hopefully we would have kind of finalized our investor kind of consortium, or if not closed the round. But in general, we are very happy to speak with people who are interested in learning about kind of emerging technologies in the hydrogen space and just the energy space. And that's the one thing that we found is the climate community has been very collaborative, for sure. So always happy to speak with anyone who's interested.
Awesome, man. Well, it's been a pleasure talking. Take care of yourself and hope we can catch up soon.
Thanks, James. It was great being on.
Nice one. Take care.